Right now, like as you're listening to this, there are millions of microscopic red blood cells just rushing through your veins.
Yeah, constantly moving.
Exactly, keeping you alive. But at the exact same moment, millions of light years away, there are supermassive black holes quietly sitting in the cold, dark vacuum of space.
Right, carrying so much gravity, they can literally tear entire solar systems apart.
Yeah, it's wild. We have biology and astrophysics, the tiny building blocks of life, and then, the massive dead engines of cosmic destruction. And usually we keep those two worlds completely separate.
Well, yeah, I mean, we have to. They operate by entirely different sets of scientific rules. You don't use a microscope to study a galaxy, right?
Right.
And you definitely don't use a telescope to find a virus.
But what if someone tried to mathematically link the two?
That is the big question.
What if a traumatized, grieving teenager figured out a way to connect the life-sustaining geometry of a human blood cell to the universe's ultimate void? Just to, make sense of his own shattered mind.
It's an incredible premise. It really is. Welcome to today's deep dive. We are exploring a deeply surreal, intensely scientific, and honestly emotionally devastating narrative by Rey Rad. It's titled, My Red Blood Cell Was a Black Hole.
Such a striking title.
Yeah. And our mission today isn't just to walk you through a story. We are dissecting a philosophical exploration of how humans use the absolute extremes of science to survive their own internal chaos.
And our guides through this material are two prodigious teenagers. First, there's Henry. He's a math and physics prodigy, but he is completely drowning in profound grief.
Yeah, after the sudden loss of his father and brother.
Exactly, a catastrophic loss. And it's compounded by a really deep betrayal from his girlfriend. So he is in a dark place. Beside him is River, a girl whose mind kind of bridges art and science, and she's navigating her own severe betrayals in this crushing isolation. So, as we unpack their theories today, I want to pose a mind-bending question directly to you listening right now. Have you ever considered that the laws governing the most massive destructive forces in the universe, like black holes, might actually share a geometric and evolutionary link with the tiny red blood cells keeping your body oxygenated right now?
It is a staggering premise.
It really is.
But to even approach the massive cosmic theories that Henry builds, we first have to ground ourselves in the microscopic world. We have to start where River's journey begins, which is with her observation of the strict, unyielding math that dictates the geometry of nature.
Okay, let's unpack this, because River is in a very dark, depressive state when she happens to watch a video about the geometry of snowflakes.
Right.
And instead of just seeing pretty ice crystals, she sees the underlying code of the universe. She becomes completely obsessed with their hexagonal symmetry.
Because she's seen the chemistry in action.
Yeah.
A snowflake's six-sided shape isn't just some random artistic flourish by Mother Nature.
Right.
It's strictly dictated by the molecular structure of water.
The hydrogen bonds, right.
Exactly. When water freezes, the hydrogen bonds between the H2O molecules, which naturally they have a very specific angled shape, force the molecules to lock together.
Making that rigid structure.
Yeah. They naturally seek the most stable, energy-efficient pattern possible. And in a flat plane, that pattern happens to be a hexagonal lattice. It is literally nature doing math to conserve energy.
That is so cool. And River's fascination pushes past basic chemistry straight into fractal geometry. She gets hooked on the concept of the Koch snowflake.
Oh, the Koch snowflake is fascinating.
Yeah. So for you listening, picture an equilateral triangle in your mind.
Right.
Now take the middle third of every single line segment of that triangle and replace it with two new lines that jet outward to form a smaller triangle.
Like a little point.
Right. Now do that again for the new segments. And if you iterate that process infinitely, you get this incredibly complex shape that perfectly mimics a real snowflake.
And the crazy mathematical quirk there is that the perimeter of the shape expands to infinity, but the total area it takes up remains entirely bounded and finite.
Which is just a mind-bending concept. And she also applies this geometric obsession to beehives, right?
She does. The beehive is the ultimate example of biological optimization. Bees intuitively use regular hexagonal grids to build their honeycombs.
Because of the wax.
Exactly. To understand why, you have to look at the biological cost of wax. It takes a bee about 8 ounces of honey consumed just to produce 1 single ounce of beeswax.
Wow, that is a massive energy expenditure.
It's huge. So they need to maximize storage space for the honey while using the absolute minimum amount of wax for the walls. And mathematically, a hexagon is the single most efficient way to divide a flat surface into equal areas with the least total perimeter.
It beats triangles.
It beats triangles, it beats squares, and circles obviously leave wasted gaps. Evolutionary pressure essentially forced bees to become master geometricians.
Okay, but if nature loves efficiency so much, and the hexagon is the ultimate biological space saver, why aren't planets or stars hexagonal?
That was a great question.
Because it feels like packing boxes into a moving truck, you know? Squares and hexagons fit perfectly flush without any wasted space. But nature keeps giving us these giant cosmic spheres. It's like pouring water into a balloon. It bulges out equally everywhere.
Well, that brings up the fundamental difference between chemical optimization and gravity-driven physics. Down here on the microscopic level, biology and chemistry are desperately trying to save energy and material.
Right, like the bees.
Right. But on a cosmic scale, gravity doesn't care about saving material. Gravity is just a brute force that pulls matter inward from all directions toward a center of mass.
Oh, I see.
Yeah. When an object becomes massive enough, like a planet or a star, that equal inward pulling force literally crushes the rock and gas into the most compact three-dimensional shape possible, which is a sphere.
So hexagons are the champions of structural efficiency on a flat plane, but spheres are the unavoidable, brutal result of massive gravitational physics.
Exactly.
So we have these two completely different rule books operating simultaneously. Biology is down in the mud, carefully optimizing for survival, and physics is up in the cosmos, just brutally crushing things together.
Which is exactly the stark contrast that serves as the launch pad for Henry and Rivers' core debate. They start arguing about whether the cold, deterministic physics of space could ever cross over into biological concepts. Like, can a galaxy experience evolution?
So Henry and River look backward to figure this out, specifically to the 19th century pioneers of evolutionary theory, so Charles Darwin, Alfred Russel Wallace, and Thomas Malthus.
Malthus is key here. He pointed out a terrifying mathematical reality. Populations grow geometrically, so 1, 2, 4, 8, 16.
Right, exponential growth.
Yeah, but food supplies only grow arithmetically 1, 2, 3, 4. That discrepancy guarantees a perpetual brutal struggle for resources.
And Darwin and Wallace took that concept and formulated natural selection. The organisms with advantageous traits survived the struggle and passed those traits down.
Exactly. But Henry looks up at the universe, and he sees black holes purely as cosmic recycling bins.
Yeah, because they're inanimate. They are governed entirely by deterministic physics like mass, gravity, distance. They suck matter in, but they don't have DNA.
Right, they don't reproduce.
They don't adapt to their environment. There is no biological intention behind a black hole.
But River completely flips that paradigm. She asks a phenomenal question. What if black holes are acting as the force of natural selection for the cosmos?
Whoa.
Yeah. What if their gravity dictates which galactic structures survive and which get shredded? And then she takes it one step further into the realm of the absurd. What if a black hole could evolve to actually control its own actions?
Are black holes just the universe's ultimate apex predator, or are they the environment itself forcing the rest of the universe to adapt?
I mean, I struggle with River's logic here, though.
Well, how can something without biology, without a genetic code to mutate and pass down, how can it evolve in any meaningful sense?
What's fascinating here is that River is demanding that we shatter our rigid, Earth-centric definitions of what constitutes life. When we look for life, we look for liquid water, carbon chains, cellular reproduction.
The basics.
Right. River proposes that the universe itself is an organism that simply hasn't evolved yet to a stage where its massive cosmic bodies exhibit cognitive features.
Oh, wow. So she's zooming way out.
Exactly. She's zooming out to a time scale that makes the entire history of Earth look like a single millisecond. In her view, the universe is still gestating. Black holes might just be the early rudimentary cellular structures of a much larger living entity that hasn't fully formed.
That is a completely staggering thought. And this hypothetical biological evolution of celestial bodies, it sets the stage for the absolute climax of Henry's scientific journey.
The nucleus void theory.
Yes, the nucleus void theory. This is where the macro and the micro finally violently collide.
And the setup for this moment in the source material is incredibly cinematic and honestly a little absurd.
It's hilarious. Henry and River sneak into a local college's science building to find an astrophysicist, and they use this fake hyperquantum fluid excuse to bypass a security guard named Vincent.
Right, and the fluid is literally just water and food coloring in a test tube.
Exactly. And they claim they are Dr. Semmelweis and his assistant Renee. They end up meeting a brilliant astrophysicist named Dr. Anderson, who playfully tells them to call him Carl Sagan.
Which is great, and he brings them into this pitch black, VR-like simulation room to show them the cosmos up close. In the dark, Dr. Anderson simulates a lone photon of light approaching a black hole. He demonstrates redshifting.
Can you explain redshifting for us?
Sure, for anyone unfamiliar, imagine an ambulance driving away from you. The sound waves of the siren stretch out and drop in pitch as it moves further away.
Oh, like that classic Doppler effect sound?
Exactly, the same thing happens to light.
Yep.
As the photon fights to escape the immense gravitational pull near the event horizon, the point of no return, its light waves are physically stretched out, shifting its color toward the red end of the spectrum.
That's so cool. And then the simulation violently shifts scales. Suddenly, instead of a black hole, they are staring at a giant enlarged red blood cell.
A huge leap in scale.
Yeah. And Dr. Anderson breaks down its structure. It's a biconcave disc. Think of a thick, round ball of pizza dough. If you squish the center down flat with your thumb, you expose more of the dough surface area to the heat of the oven.
That's a great analogy.
Thanks. A red blood cell does the exact same thing. It squishes its center to expose more surface area, allowing the hemoglobin inside to absorb and transport oxygen and carbon dioxide as efficiently as possible through the body's tiny capillaries.
And here is the crucial biological detail that Henry latches onto. Early in a red blood cell's development, it actually contains a nucleus, just like most other cells.
Right.
But as it matures, it deliberately expels its own nucleus. It ejects its core to achieve that squished biconcave shape so it can carry more oxygen and sustain life.
In hearing this, Henry pitches his grand theory.
Yeah?
What if a black hole did the exact same thing? What if a black hole, after eons of chaotic, destructive consumption, somehow expelled its singularity, its infinitely dense core where all physics breaks down?
And leaving behind an empty gravitational shell.
Yes. A shell that mimics the biconcave shape and the life-sustaining circulating loop of a red blood cell. He names this theoretical cosmic structure the nucleus void.
The nucleus void.
But here's where it gets really interesting, because structurally that makes absolutely no sense. It's like trying to take the pit out of a peach without breaking the skin.
Right.
The peach stays intact because of the flesh, but if you remove the singularity from a black hole, the actual engine generating the infinite gravity, what on earth is generating the gravity to hold this cosmic cell together? It completely breaks all known laws of physics.
Oh, it shatters them. Dr. Anderson immediately points out that the fundamental forces governing massive celestial bodies and microscopic cells are entirely incompatible. You can't just swap the math.
So Henry is just totally wrong.
Well, scientifically, yes. But if we connect this to the bigger picture, Henry isn't really theorizing about space anymore.
Oh, I see.
Yeah. When a kid who has lost his father and brother starts obsessing over how a deeply destructive force can miraculously expel its darkest core to become life-sustaining, well, he's not talking to black holes. He's talking about himself.
He is trying to figure out how to survive his own gravity.
Exactly. Henry is the black hole in this metaphor. He is consumed by this dark, infinite gravity of grief and anger that destroys any relationship that gets close to his event horizon.
Oh.
The nucleus void is his desperate, subconscious blueprint for psychological healing. He's mathematically trying to figure out how to expel the destructive singularity of his own trauma so he can become a vessel that sustains life again.
That transition from theoretical space into the internal mind space is where the narrative really digs its hooks into you. Because to survive their severe trauma and isolation, both of these teenagers have constructed these elaborate, highly defended mind palaces.
And these aren't just daydreams. These mind palaces are incredibly complex survival mechanisms, complete with alter ego figures.
Right. Henry's figure manifests as a sharply dressed, hyper-intellectual, arrogant version of himself in a black suit. And he does absurd things like drink coffee out of a wine glass.
It's an armor of detached sophistication.
Exactly. While River's figure is much more visceral, hers is a fierce protector who originally wielded a sword and wore long black boots.
Because River's isolation required a defender, someone who could mentally cut down any threats. And these mental constructs have terrifying weight to them.
They really do.
In one sequence, River actually navigates into Henry's mind palace and discovers a room that is a literal bloodbath.
It's horrific.
It is, but psychologically it makes sense. Henry has so much pure, concentrated anger toward the people who hurt him, specifically his father and his ex-girlfriend Maddie, that he couldn't process it.
So it just manifests as this room?
Right. When you can't solve the equation of your own grief, you build a containment unit to lock it inside. He banished their memories to a bloodbath.
And seeing this level of compartmentalized agony forces River to confront the concept of mental walls. She develops this philosophy that from childhood we are instructed to build walls inside our minds. We build walls out of concepts like trust, cultural norms, or the strict rules we read in textbooks.
And River argues that while these walls organize our thoughts and make us feel safe, they ultimately act as a prison. They limit the size of the universe we are capable of experiencing.
Her solution is radical. She wants to tear all the walls down.
Right.
But hold on. So what does this all mean? Aren't some walls necessary for our sanity? I mean, if our minds are houses, taking down a decorative cultural wall might just open up the floor plan and let some light in. But what if you knock down a load-bearing wall?
That's the danger.
The roof caves in. Doesn't River realize that some of these defensive walls, even the ugly ones, are the only things keeping Henry's psyche from completely collapsing?
You've identified the central peril of trauma recovery right there. And River ultimately learns that reality the hard way. When the trauma originally occurred, those imaginary figures in those massive walls were load-bearing. They kept the teenagers alive.
Yeah.
But over time, a defensive structure can become parasitic. A protector that constantly wields a sword eventually prevents you from ever hugging anyone.
The protectors turn into jailers?
Precisely. Henry's figure becomes increasingly arrogant and isolating, preventing him from connecting with anyone. River's figure becomes violent and controlling.
So how do they get out?
Well, the narrative makes a profound psychological point. True healing cannot happen inside the mind palace. You cannot recover by retreating into a highly controlled mental labyrinth where you get to play the god of your own suffering. Real healing demands the terrifying vulnerability of stepping outside the walls and living in the unpredictable present.
Stepping outside your walls when the rest of the world is fiercely defending theirs is incredibly dangerous, though. It takes immense bravery. And to encourage Henry to keep pushing his wild, boundary-breaking nucleus void theory, River tells him a historical story.
Yes.
She brings up Dr. Ignaz Semmelweis from 1840s Vienna.
The story of Dr. Semmelweis is one of the most tragic and illuminating chapters in medical history.
It really is.
He was working in a hospital with 2 maternity clinics, and he noticed a horrifying statistical discrepancy. Mothers in the clinic staffed by doctors and medical students were dying of puerperal fever or childbed fever at vastly higher rates than the mothers in the clinic staffed by midwives.
And the key difference in their routines was deeply macabre.
Oh, absolutely.
The doctors and medical students were frequently coming straight from the morgue where they were performing autopsies on cadavers directly to the maternity ward to deliver babies.
Unthinkable today.
Completely unthinkable. And the midwives were not doing autopsies.
And you have to keep in mind the germ theory of disease did not exist yet.
Right.
The prevailing medical belief was miasma theory, which is the idea that diseases were spread by bad air. But Semmelweis looked at the data and hypothesized that the doctors were carrying what he called cadaverous particles on their hands.
So he mandated a strict new policy. Anyone entering the maternity ward had to wash their hands in a chlorinated lime solution.
And the results were immediate and undeniable. The mortality rate plummeted. It was a verifiable, data-driven miracle that was saving women's lives.
It's one thing to have the courage to tear down your own internal walls, but how do you survive when the rest of the world fiercely defends theirs? It makes you wonder how many world-changing ideas we are ignoring right now just because they make us uncomfortable.
This raises an important question because the established medical community violently rejected him. They were deeply offended.
Because of their egos.
Mostly, yes. The psychological component here is crucial. The doctors didn't just reject Semmelweis because of scientific snobbery. If they accepted his hand-washing rule, they had to accept the horrifying reality that they were the ones who had been killing the mothers.
Oh, wow. Their unwashed hands were the murder weapon.
Exactly. They couldn't face the guilt, so they protected their egos.
Yeah.
Their mental walls were so thick that they chose to let patients keep dying rather than admit they were wrong. They mocked Semmelweis, forced him out of the hospital, and he eventually suffered a nervous breakdown. He died in an asylum after being beaten by the guards.
It is so tragic. And River uses this tragedy to deliver a vital lesson to Henry. Henry is looking at his equations, bridging black holes and red blood cells, and he thinks he sounds insane.
Right.
River is telling him that true innovation requires sounding crazy to the establishment. Semmelweis sounded insane to the doctors of Vienna, but he was absolutely right.
She is validating Henry's struggle. She's telling him that even if his theory breaks every known law of physics today, he has to have the courage to pursue the truth beyond the accepted walls of current understanding.
It is a profound act of faith in another human being's mind, and it brings us to the culmination of an incredibly dense emotional journey today. We've traveled from the strict energy-saving mathematics of a freezing cold snowflake out to the theoretical event horizon of a supermassive black hole, and deep into the blood-stained, labyrinthine hallways of a traumatized teenager's mind palace.
Rey Rad has masterfully utilized the absolute extremes of scientific disciplines. By contrasting the microscopic efficiency of biological survival with the macroscopic destruction of astrophysics, the author maps the darkest complexities of the human heart. It is ultimately a story about the mathematics of processing the things that crush us.
So true. And as we wrap up this deep dive, I want to bring this concept entirely back to you listening right now. Whether you are prepping for a high stakes boardroom meeting, studying for an impossible exam, or just trying to navigate the messy, complicated relationships in your own life, remember the concept of the mind palace. The walls that you allow to remain standing inside your own head. The walls built by your culture, your unrecognized biases, your past traumas, and your assumptions. Those walls dictate the absolute maximum size of the universe you get to live in.
And if you never question the structural integrity of your own deepest beliefs, you will forever remain trapped in the labyrinth you built to keep yourself safe. You'll survive, but you won't truly live.
So, I want to leave you with a final lingering concept to mull over on your commute or while you drink your coffee today. We talked about how telescopes and microscopes show us entirely different worlds and how Henry tried to merge them to find a way to heal. If our minds are truly like universes and trauma creates emotional black holes that violently consume all of our light and joy, is it possible that passing straight through your own personal event horizon is the only way to finally expel that destructive singularity and give birth to an entirely new, life sustaining version of yourself? Something to think about. Until next time.